guys, today we're going to take another look at rational root theorem. But today, I need you to feel comfortable with finding the list and using factoring to find all solutions. So what I'd like to do is take a look at 3 examples, and I'm going to write out the steps next to it. So in our very first step, whatever your polynomial is, you need to make sure your polynomial equals 0. Typically, in rational root theorem problems, it's already going to equal 0. After that, determine the possible rational roots. That's what we did last class. So I'm going to take a look at my constant and ask myself what 2 numbers multiply together to give you 12. 1, 12, 2, 6, 3, and 4. Then look at the leading coefficient, which is 1. That's prime. So the only numbers that multiply together to give you 1 is 1. So my total list is 1, 2, 3, 4, 12, and 6. That's where we stopped last class. Remember that my promise to you is that when you look at these list of numbers, you want to disregard fractions, and of the 2 smallest ones, the positive or the negative will work. In other words, for this problem, I promise you that either positive 1, negative 1, positive 2, or negative 2 will work. So now we just have to use guess and check with synthetic division, and we need to make sure our remainder is 0. So I'm going to say let's try negative 1 first. Okay, so we have negative 1, then 1, 2, negative 11, and 12. When you use synthetic division, drop the 1, multiply 1 by negative 1 to get negative 1, add 2, which is 1, and repeat that all the way down. You will notice that for this particular case, negative 1 works. Once you find one that works, you skip to step 4. So if negative 1 didn't work, then I would need to keep trying until I found one that did. Step 4, we're just going to take this bottom part of our synthetic division to write down our new polynomial, and then we're going to factor. Since this one is 3 terms, I'm going to do X method. Since A is 1, it's the normal X method. So I need 2 numbers that multiply together to give you negative 12 and add to give you 1. That is 4 and negative 3. Once you have 4 and negative 3, we're going to put them inside binomials. X plus 4, X minus 3. Now, when you go to find the solutions, we're going to take them out again, so their signs would change. So I have negative 4 and positive 3. So I should have 3 answers here because of my original problem, my original polynomial is a degree 3, which tells me 3 answers. Negative 1, negative 4, 3. The answer that's left out the most is the one from the synthetic division. So be careful with that. Make sure you include it. So again, after you find one root or solution or 0 that works using synthetic division, then you're going to rewrite your polynomial using the synthetic division and factor using the think it through, making sure that you have the same amount of answers as the degree from the original problem. So I'm going to take a look at that a couple more times, keeping these steps in mind. So we have our polynomial equals 0, determine your rational roots, guess which one is going to work, remember my promise, okay? Then after you find one that works, factor, okay? So let's try this again. Example 2, I have 2x to the 4th plus x cubed plus x squared plus x minus 1. That's already going to be equal to 0. So now I have to determine my potentials. My constant is 1, which is prime. My leading coefficient is 2, so the only 2 numbers that multiply together to give you 2 are 1 and 2. So my options here are positive 1, negative 1, positive 1/2, negative 1/2. Remember, my promise is that fractions don't count. So really, you know either positive 1 or negative 1 should work. So here's me working out negative 1, and lo and behold, it works. Once you find one that works, skip to step 4. Write down your new polynomial, 2x cubed minus x squared plus 2x minus 1. Now factor. Since this is 4 terms, we're going to factor by grouping. Take out a GCF from each one, and don't forget about your checkpoint. Double check that the binomials match. They do. So I have 2x minus 1 and x squared plus 1. So now from here, separate them, set them equal to 0, and solve. So I should add 1 and divide by 2 for 1/2, then subtract 1, square root. Don't forget your plus or minus, and I get I. So my 4 answers here are negative 1, 1/2, plus or minus I. Remember, plus or minus takes care of 2 answers. Let's try one more. I've got 2x to the 4th plus 3x cubed minus 6x squared minus 6x plus 4. Already equals 0, so I need my factors of 4, 1, 4, and 2, and my factors of 2, 1, and 2. So now from here, I'm going to divide. So 1, 4, and 2 divided by 1 is just itself. And then when I divide by 2, I've got 1/2 and then 2 and 1 again. Make sure you don't repeat them, okay? Now my promise to you, again, don't worry about the fractions, and the smallest 2 will work. okay? Now, even though I'm telling you don't worry about fractions, I would like to show you one that works. When you evaluate with the fraction, instead of thinking about it as multiply by 1/2, think about it as divide by 2. So here I go, I drop the 2, divide by 2, add, divide by 2, add, divide by 2, add, divide by 2. Look at there, it worked. So now I have to skip to step 4, where I am going to write my resulting polynomial. So I've got 2x cubed plus 4x squared minus 4x minus 8. Then we're gonna factor by grouping, okay? Or actually just factoring. Take out that common GCF of 2, so that divides everything out, makes my number smaller. Then group the first 2 and the last 2. The first group has an x squared in common, so I've got x plus 2. Second group has a negative 2, x plus 2. That's your checkpoint, so we're on the right track. So then my resulting binomials are x plus 2 and x squared minus 2. Now I have to set each one of those equal to 0 and solve. So x plus 2 is going to give me a negative 2. Then in the next one, I need to add 2, square root, and don't forget about my plus or minus. So I have plus or minus root 2. So my 4 answers are 1/2, negative 2, plus or minus root 2. Your turn.